Our climate is changing. The world is warming. Sea levels are rising faster than ever, and extreme weather is becoming more frequent and more intense. The science is clear. Human actions are to blame. Climate change is the defining crisis of our time. We are in a climate emergency. I've spent most of my career trying to measure the climate impacts of our actions in the hopes that governments can identify the best policies or businesses can find the right strategies to help us slow the damage. Since the Industrial Revolution, the world learned to produce everything faster and cheaper. As societies got richer, we produced more and consumed more energy, more materials, and more food. What we need is a new industrial revolution, a new playbook that decouples growth from emissions. That revolution is gaining momentum. Energy powers our economies. But energy is responsible for 80% of all greenhouse gases produced, the key culprit behind our warming planet. How do we slow down those emissions? One way is to electrify, and to power that electrification with clean energy. Solar is one of the cheapest and most accessible sources of energy on Earth. But when land is scarce, like in Singapore, engineers need to get creative. This solar farm floats on one of the city's reservoirs.
We built a 60 megawatt peak system that can actually power up 16,000 HDB flats. That translates to 32 kilotons of carbon emission offsets that we can produce.
That's enough to power Singapore's 5 local water treatment plants, making Singapore one of the few countries in the world to have a 100% green waterworks system. Sembcorp took a little under a year to build this, one of the world's largest floating solar farms. They're now ready to apply the same idea on waters elsewhere.
We have a target of 10 gigawatts. With all the lessons and innovations that we have learned, we want to work with the neighboring countries to develop renewable energy together with them.
There's even more good news. Apart from having solar panels float on water, researchers are already studying how they could be pasted on the glass or skins of buildings, or on cars, buses, or almost anything. All of this could give solar farms a bigger footprint. But the biggest drawback about solar is that it can't always be on. New research on other renewable sources could help, like geothermal energy. The most common way to harvest geothermal energy is by drilling a well deep underground, then piping the heat up to power a turbine which generates electricity for a grid. But exploration to find hot fluids underground are an expensive and time-consuming process with no guaranteed results. Ever wants to make geothermal energy much more accessible and scalable. They use a series of multilateral wellbores called an everloop. Fluid is circulated through the everloop, which is then naturally heated by the earth through conduction. When the hot working fluid reaches the surface, the heat picked up underground can be used to generate electricity. It's a reliable and consistent energy source, and it can be deployed anywhere, especially near cities.
They're all underground, very low structures. So the beauty of this thing, you can fit it anywhere and you don't have to look at it, and land can still be used for recreation or agriculture or whatever else you want. So that is a huge win-win.
Making the transition to this new energy source requires construction and professional expertise. That kind of talent is already available in the oil and gas industry.
They don't need any retraining. So all of a sudden you're an oil and gas guy, you're sitting there, oh, actually, I am for the green revolution because I know I can still earn a living doing that. I can still feed my kids. People can redeploy their existing skills on this whole new green industry that has so many other advantages.
There's another source of renewable energy that's been around much longer: nuclear. Nuclear fission makes up 10% of the world's energy mix. the highest among all low-carbon sources. But nuclear's reputation precedes it. Research is underway on a safer type of reaction, nuclear fusion.
The word nuclear has a bad reputation as long-lasting waste and the problems of Fukushima and Chernobyl. But fusion is a different thing, it's a different process, it has very different radiological hazards, and it should be treated as a different source of power.
This is how fusion energy is created. Fusion fuel is a hot gas of two heavy forms of hydrogen, which are fused to form helium. In the process, some of their leftover mass is turned into energy.
One of the beauties of fusion is that it is so energy intensive. This is really the holy grail in a sense, that you've effectively got inexhaustible fuel, and yet it could supply electricity for all of us continuously and in a carbon-free way. But it's really hard to do because you're dealing with a fuel which is so hot, and so sustaining that temperature and holding the fuel in a stationary way is then a big challenge.
Fusion reactors are difficult to make because they must withstand temperatures of up to 150 million degrees Celsius, 10 times hotter than the sun. The kind of heat needed to fuse atoms melts most machines. ITER at the south of France is the world's most expensive science experiment designed to achieve fusion at scale. The UK's Atomic Energy Authority are members of the ITER project, but they're also building a much smaller reactor. Scaling down makes commercialization easier.
ITER is big and it is quite expensive. And if the power plants that follow ITER, you have to raise sort of $20 billion each time you want to build a power station, that's quite hard to do. And so you also want to find ways of making it more economically attractive. And that could be making it smaller, drive down the scale. People have got to want to buy it. If it's too expensive, people won't buy it. And then people have got to want it and accept it and understand it and be in favour of it. All of those things have to happen for that ecosystem to really work.
A movement to decarbonize is underway, and not just in industrial settings. As the world seeks new ways to harvest clean power, efforts are already underway to help us use energy more efficiently. In Singapore, air conditioning is quite the necessity to beat the heat. But cooling accounts for much of the city's energy usage. In homes, it makes up almost 30% of energy bills, and electricity consumption in buildings and households make up about 20% of the country's overall annual carbon emissions. A new approach can make cooling cheaper and more efficient. The city's largest energy provider, SP Group, designed a centralized cooling system for the city's iconic Marina Bay Financial District. It's installing a similar system at a housing estate. Centralized cooling works like this. On rooftops of blocks, water is chilled. Solar panels nearby partially power the refrigeration process. The chilled water is piped to homes, where a fan coil unit creates cool air from the chilled water and cools the apartment. A centralized and professionally managed chiller makes cooling more efficient, compared to the conventional setup with many small chiller units placed throughout an apartment block.
It will give them at least up to 30% energy efficiency. Energy efficiency should translate into savings for them, and in the long run, it also enables them to not just save money. The next generation will have a planet which is not destroyed by all this ozone-depleting refrigerants, but they're able to stay cool, they're able to have thermal comforts, quality living, but at the same time still protect the planet for the next generation.
The town has other smart technologies meant to reduce energy, like an app that gives residents a reading of their energy consumption on demand.
And you can actually compare that to other households in Singapore. So you can actually know whether you are faring ahead or actually behind the national average and take actions towards that.
Renewable energy holds the promise of a sustainable future, but it has to go hand in hand with electrification. Heavy transportation like shipping, aviation, and trucking are hard to abate.
You can't electrify them directly. You can't plug a cable into a marine vessel and make sure that it works on clean power.
Since big machines can't be powered by batteries, hydrogen could be the energy carrier instead. Haldor Topsoe is a Danish company working on developing green hydrogen. That's hydrogen created from renewable energy. They've developed a solid oxide electrolyzer cell, which uses electrical power to split water to produce hydrogen. The electricity comes from renewable sources, making it green hydrogen. No carbon or harmful toxins are emitted from the process. And the electrolyzer cell delivers 30% more hydrogen output compared to other technologies. Hydrogen could then be used to make ammonia, which could power ships.
Until recently, it was completely off the charts. You hadn't have this development. But now, more and more, there is a tremendous awareness coming in these kinds of sectors to generate more and more clean power for transportation. Just like what happened with solar and wind. 25 years ago, it was extremely expensive to deploy solar parks or windmills. But now, the industry has gone through a learning curve. And I am absolutely convinced that with our technology, we will do the same.
In Singapore, the PSA studies these developments closely. It operates Singapore's container port, the largest transshipment hub in the world.
Besides hydrogen, there are alternatives that we can actually explore using. Ammonia, organic hydride are among other hydrogen vectors that we can use. Using hydrogen in its purest form or in other vectors whereby hydrogen is stored in other compounds. So if we can use all those fuels directly, then you actually reduce the energy that's needed to create them and also improve the cost outcome. Singapore is in a unique leadership position. We are the global leading bunkering hub. So we have to be stewards for the maritime industry and also the global supply chain. So whatever we are doing is really to not just reinforce our current status, but also to then elevate us, propelling us to not just a global leader in supply chain, but one that takes the lead in sustainability outcomes.
Another source of sustainable liquid fuel has already been commercialized. The challenge now is to achieve greater adoption. At Neste, a variety of wastes and residues such as used cooking oil and animal fats from food processing waste arriving from the region are processed into renewable diesel and other renewable products. The fuel, known as Neste My Renewable Diesel, is a drop-in solution, so it's fully compatible with diesel engines. It can be blended with normal diesel or use neat. According to Neste's calculations, based on the EU Renewable Energy Directive, its renewable diesel releases 90% less greenhouse gas emissions over the fuel's life cycle compared to fossil diesel. Here's why. Emissions from fossil fuels don't circulate because the carbon bound in oil or coal has been out of circulation for millions of years. Any emissions are considered additional when released into the atmosphere. And that's why it speeds up climate change. On the other hand, Neste My Renewable Diesel is made largely from waste and residues, including those from vegetable oil processing and used cooking oil. Renewable raw materials during their lifetimes soak up carbon dioxide through photosynthesis. When renewable diesel is burned, it releases CO2. But what is returned to the atmosphere is equal to the amount absorbed by the plants earlier, so CO2 is circulated.
Even in a pandemic environment, there is about 800 million tons of diesel being consumed on the planet every year. And that is expected to rebound again to 900 million tons. 70% of that is heavy-duty transportation. If we would even achieve 50% electrification in road transportation, let's say by 2030, well, there is still 400 million tons of fossil-based diesel being consumed in the world. So that means that our renewable diesel still has a huge opportunity to help decarbonize and replace that fossil-based diesel.
Neste also produces sustainable aviation fuel, or SAF as it is commonly known. SAF, used neat, helps reduce greenhouse gas emissions over the fuel's life cycle by up to 80% compared to fossil jet fuel. 300 million tons of fossil-based jet fuel was used on average before the pandemic. Because of the sheer volume of flights worldwide, the carbon-cutting potential is massive. But SAF doesn't come cheap. It's currently 3 to 5 times more expensive than conventional jet fuel. The higher cost prevents a wider uptake and, in turn, makes the prospect of scaling up supply difficult. Singapore's national carrier, SIA, first trialed sustainable aviation fuel in 2017 on over 3 months of flights between Singapore and San Francisco.
We saved 320 tons of carbon dioxide. Also, in 2020, we deployed SAF on our flights between Stockholm and Moscow. And we continue to look out for opportunities to deploy sustainable aviation fuel on more flights.
The airline aims to steadily increase its use of SAF to achieve carbon neutrality by 2050. And they're not going at it alone.
I think it takes two hands to clap. If we are able to stimulate higher sustainable aviation fuel demand from the travelling public, this would give us a chance to break that vicious cycle and lower the price of sustainable aviation fuel, making it a lot more affordable for everyone to travel sustainably.
An energy revolution is gathering momentum, with solutions already in place to enable clean and renewable power to be harvested everywhere, along with new technologies to make our consumption of energy much more efficient, and new solutions for liquid fuels to decarbonize sectors that are typically hard to abate. The time has come now for humanity to make the switch to a more sustainable energy future. Our carbon footprints are larger than we realize. From the buildings we live in to all the things we surround our lives with, everything is embedded with carbon emissions. At the rate we're consuming and producing our materials, we are headed for a climate emergency. Plastic, a wonder material that changed manufacturing forever and revolutionized the global economy. Durable, light, and used in practically everything. The problem is, producing it is very carbon intensive. Plastic is made from crude oil. It's processed into monomers like ethylene, then polymerized into polyethylene, which then becomes plastic pellets. They're then melted and molded to make products. As much as 8% of the world's total oil supply is used to make plastic. And producing or incinerating plastics produces 850 million metric tons of greenhouse gases a year. That's equal to 180 coal-fired power plants. Up to 4 to 8% of all plastic is recycled. And when it isn't disposed correctly, it pollutes the environment and even harms our food supply.
We want to make sure that we have the right and the most advanced technologies in place to ensure that the plastic waste is being recycled, therefore contributing to a circular economy.
The Alliance to End Plastic Waste works with venture capitalists, financial institutions, and private investors to channel much-needed funds into research on new technologies to end the world's problems with plastic waste.
The value of the plastic waste that enters the environment ends up in open dump fields or in incineration today, or in landfills for that matter, has a value estimated of between $80 and $120 billion. A value that today is lost, but doesn't have to be lost.
One of the Alliance's many partners is CRDC, the Center for Regenerative Design and Collaboration. In Costa Rica, the company collects all types of plastic waste and converts it into a high-value concrete modifier that's used in making a new type of concrete.
We can show a real working example of the circular economy. We're going to be converting 90 tons a day of waste plastic that no one wanted and in fact had a negative value. That negative value we're going to convert into appreciating assets that will make a real difference to infrastructure and the community.
Plastic waste of all sorts is collected. This plastic is shredded into small pieces and batched by density. It is then preconditioned with a special mix of mineral additives before being sent to a heat extruder. Subsequently, this mixture is cooled and granulated into fine particles, and Resin 8 is born. Resin 8 can be added to a wide variety of structural concrete products to either decrease weight, increase strength, or even provide better insulation and acoustics.
people understand that we need to make a change. We need to make a change specifically in this plastic problem.
While recycling picks up speed, new research into more sustainable substitutes for plastic is underway. RWDC produces Solon, a raw material that could be used to replace plastics in some products. Solon is a biologically benign material made from plant-based oils, like used cooking oil. The used cooking oil is converted to a type of polymer called PHA by microbes during fermentation. When fermentation is complete, the PHA is separated and compounded into a resin. These PHA resins are used as a drop-in replacement for traditional petroleum-based resins to make single-use articles people use every day.
And as we examine every known living system, we find the same thing, that PHA is made and utilized in nature, and it's ubiquitous.
Because it's a natural material, Solon is biodegradable when it's placed in landfills. It also has a fraction of the carbon footprint compared to regular plastic. When it's done being used, a product made from Solon gets a second life.
We can use it to recycle and remake an article. We can use it to make other articles different than what it was originally, or we can use it in a composting scenario where it then becomes organic matter that we can use for growing food crops. We can also use it as animal food. So the end result of an article made with Solon can be a wide array of possibilities, and it gives us options that we don't have with other materials.
Plastics aren't our only obsession that's costing the Earth. There's also clothes. Textiles are the second largest polluter in the world, producing 10% of global carbon emissions and nearly 20% of wastewater. The fashion industry sucks up more energy than the aviation and shipping sectors combined. Consider the life cycle of clothes, from growing cotton in the fields to processing it into threads, then fabric, and finally into a piece of clothing. The clothes also need to be stored and then distributed, so there's carbon emitted at every step. And then they quickly add up because everyone buys clothes and we're buying them more often. Clothes also need to be washed and ironed and often disposed. Clothes produce up to 10% of the world's global carbon emissions, and more than 80% of all clothing finally ends up in landfills or incinerators, which also release carbon emissions. Scientists are now learning new and more efficient ways to produce clothes. LanzaTech has a circular economy approach using waste as a resource. It's diverting flue gases from smokestacks. A bacteria ingests the gases and turns it into ethanol through a process of fermentation. Ethanol then becomes the building block for a range of products, clothes included, that would have been produced with petroleum.
The way to think about ethanol is to really think about ethylene. Today we use ethylene that's made from petrochemicals, and it is converted to everything you use in your daily life. Polyethylene for bottles, polyester for your clothes. All we've done is we've made ethanol, make that ethanol into ethylene, and then that ethylene is exactly like a petroethylene, and it can be used to make everything we use in our daily lives.
LanzaTech is scaling up its impact by working with mainstream consumer brands, eager to reduce their products' carbon footprints.
As more people get better quality of life, they'll start to buy more things. We don't want those things to come from fresh fossil carbon. And so that's what we're trying to show, is that these things are possible and that there is a future where we can decouple our fossil life from our everyday life.
That decoupling is gaining momentum. About 75% of all clothes contain cotton. That involves farming, which is highly resource and carbon intensive. This American startup has developed a much more efficient process. It makes cotton grown from cells in a lab.
It's faster and more efficient because we don't have to grow the whole cotton plant. So if you go to the field, it will take 180 days to grow the whole cotton. and 120 only to grow the plant. So what we do is we leapfrog the process by growing from a single cell directly to the cotton fiber.
Galley's approach demonstrates many advantages of growing cotton this way. It's grown all year round in a controlled setting, so production cycles are consistent, regardless of the weather outside. Perfect for supply chain management. Less land is needed, and the process uses just 15% of water required to grow cotton in a field. That's 1 billion liters of water that gets saved for every 1,000 tons of cotton produced. There are savings on carbon emissions too.
So in terms of CO2, the production of cotton today requires 220 million metric tons every year. So this corresponds to approximately a car driving the entire Earth 3 times. So in our process, it's carbon neutral.
While cotton gets a makeover, new technologies are being developed to make a different kind of leather. These leather products are made not from the hide of animals, but from mycelium, a fungal thread that's found deep underground.
Mycelium are nature's recyclers. They take things that are waste products, dead trees, plants, bugs, old mushrooms, and biodegrade them and turn them into new mushrooms and new mycelium. And this is in contrast to leather, where you raise a cow intentionally for the meat for 2 or 3 years or for the milk, and then take that cow to slaughter and have a hide.
Mycelium is grown in under 2 weeks using Bolt Thread's approach. It is processed to make Milo, Bolt's patented name for the fabric it produces. It looks and feels like leather, but does away with greenhouse gas emissions associated with raising livestock. Milo is now being used by some of the world's biggest fashion brands.
A huge swath of consumers look at this planet and watch climate change ravaging much of what we know and love. And they want to put their dollars and their purchasing decisions to work in a way that's helpful, not harmful. And what we find is that brands are eager to adopt sustainable alternative materials for the roughly 100 billion units of apparel we make on this planet every year and move them to something more sustainable.
Another leather-like product that's also been commercialized is Piñatex. It's made of waste in pineapple farms. Pineapple leaves are typically burned after the fruits are harvested. Those leaves are now spared and used as feedstock to produce Piñatex.
In 2020, we actually used 825 tons of pineapple leaf waste, and that is an equivalent of 264 tons of carbon dioxide equivalent not being released into the atmosphere. And very concretely, that represents about the emission used by if you charge 33 million smartphones.
It's not just an ecological solution. The approach is good for business and communities too.
The triple impact, economic impact, social impact by creating new jobs and opportunities, and an environmental impact by obviously reducing the carbon footprint is really at the heart of all the decisions we make, is the core business model we work on.
Clothes, bags, and plastics are getting less wasteful. What about whole cities? As societies get richer, cities develop. Construction may be good for economies, but it's one of the biggest culprits of climate change. Much of the sector's carbon emissions come from cement production. Cement is the stuff that holds concrete together. Half of the emissions produced come from producing the heat required for the production process. The other half comes from just using limestone, the key feedstock for making cement. Limestone is calcium carbonate. When it's heated, 44% of its waste is released as CO2. Altogether, for every ton of cement produced, almost a ton of CO2 gets released.
Cement is the second most consumed thing on Earth behind water. There's 4 billion tons of it produced a year. So when you take just the amount of CO2, 0.8 tons of CO2 per cement produced, and the fact that it's 4 billion tons per year, it's clear why that leads to 8% of the world's CO2 emissions coming from cement production.
At a plant in California, CO2 emitted as exhaust from the cement manufacturing process is converted into a material that works just like cement.
We really took our cues or our inspiration from nature. So the same way coral reefs form in nature and how shells form in nature, instead of emitting CO2, they're actually taking CO2, absorbing it, and creating a reactive form of limestone. If you talk specifically about our process, we're taking that same feedstock of limestone, we're putting it through a kiln, we're emitting CO2, but then we're recapturing that CO2 to make this form of reactive limestone. And we've engineered it in a way that it can be used both as a partial replacement to existing Portland cement or as a 100% standalone cement.
It's a bolt-on process, which means cement producers don't need to make any upstream changes to their feedstocks, machinery, systems, and processes, which they've already invested heavily in. It makes the technology easily adoptable and scalable. Another company in Canada also sees CO2 not as a waste, but as a resource. Svante designed a proprietary filter system that traps CO2 from high-polluting plants such as cement, limestone, and hydrogen. CO2 produced from cement manufacturing is typically released through smokestacks. Svante's technology captures the CO2 before it's released into the atmosphere. This is how it works. The flue gas is diverted to a rotating system where carbon dioxide is trapped by Svante's nanofilters. When the filter is saturated, the CO2 is released for storage. The CO2 can then be part of cement manufacturing for carbon-cured concrete or safely stored underground. Svante says each of their plants can capture 1 million tons of CO2 in a year, and at a cost that's half of other conventional carbon capture technologies.
Part of the challenge for smaller players in industry is that it's very difficult for them to adopt new CO2 capture technology. Svante is developing a solution that is simpler, less complex, and less expensive, so that smaller players and smaller manufacturing plants or smaller emitters can adopt the technology, and it can be widely adopted globally.
In Singapore, sustainable building materials are being applied on an unprecedented scale. The city's Tuas megaport uses a material called ground granulated blast furnace slag, a byproduct of steel production. The process reduces cement use by 75%. The project uses 5 million cubic meters, about 2,000 Olympic-sized swimming pools worth of carbon-cured concrete embodied with CO2 that was captured from the concrete manufacturing process.
It will save us 1.3 million tons of CO2. And that is equivalent to removing 260,000 petrol cars from the roads permanently. A lot of people think that it will cost an arm and leg to use green materials, but what we have proven is that we can do this safely, reliably at this scale, maybe at a marginal cost escalation. And that's a very important signal to the industry that it is time now to embrace the use of green materials.
We've arrived at the dawn of a new industrial revolution, where waste becomes resource, where materials get a valuable second life or as many lives as possible, and where they are created much more efficiently. The stage is now set to inspire greater adoption and more innovation to help sustain all our material needs for generations to come. Food. It sustains us and so much more, but it could soon run out. Affluence is driving up consumption, so is growth in populations. At the rate we're eating, the world needs to grow as much as 70% more food in just 30 years. An unthinkable target if how we eat and grow our food remains unchanged. This is agriculture as we know it today, a land, water, and energy-intensive industry. Also well known is its greenhouse gas emissions. Forests are nature's carbon sinks, and when that's cleared for farming, more carbon is released to the atmosphere. Modern agriculture also involves machinery, which burn fuel, and there's fertilizers, which also have a carbon footprint. And since farms are located far away from cities, the food miles also drive up carbon emissions. Even before it reaches our plates, food would have already released 10% of all greenhouse gas emissions globally. Vertical farms grow fruits and vegetables much more efficiently. This is a Bowery farm. It's 100 times more productive per square foot than a traditional farm. It's also packed with technology that controls every aspect of the farm's environment.
You have this powerful recursive learning loop that's iterating, testing, watching, iterating, testing, watching at a very large scale, which is helping to drive not only increases in yields, but really exciting, fun, vibrant taste and flavors in the crops that we grow themselves.
Because conditions are so carefully controlled, Bowery grows a diverse variety of crops. That includes many that are just too fragile for traditional farms and long distribution journeys. The farm is just outside the city, so distribution is cheaper and faster, and produce fresher when it reaches the stores.
We think about sustainability as being multi-dimensional. And so it's of course the component of resources, but it's also economic sustainability and commercial sustainability. And so we think a lot about how do we make sure that we can democratize access to high quality fresh produce. Everybody should be able to try great flavorful produce all the time.
While Bowery makes farms more efficient, Unfold selects and develops seeds that are more productive for vertical farming.
There's been a lot of investment in this sector, but it's really been focused on the infrastructure of the farm. Really amazing state-of-the-art facilities to grow the crops. What was missing was the genetics or the seed that really is optimized to be grown under those conditions. So you want to have seed that actually can respond to all that environmental control, that really is optimized for production under artificial light with the systems that control all the other environmental pieces.
Another type of farming is headed for a reboot. Livestock makes up half of global methane emissions. Methane is a greenhouse gas, and it's 26 times more potent than CO2. But new technologies in our midst are making us rethink what we know of meat. The Impossible Burger. It's claimed to taste exactly like meat, but it's made from plants. It even bleeds like a medium-rare burger. The protein-packing burger is made from soy and potatoes, and the fats come from coconut and sunflower oils. There's also a mix of flavor ingredients along with heme, which provides the look, feel, and taste of meat.
Heme's not only responsible for the flavor of meat, it's also a basic building block of life on Earth, and it's present in every cell. And so what our scientists discover is you could also get that from plants. We started by extracting heme from the root nodules of soybeans, and that's why our heme is called soy lake hemoglobin. So we then adapted to do a fermentation process, and essentially you're growing that same heme that's found in the roots of soy, but you're growing it in yeast, and then that makes it much more efficient, much more scalable, and so we're able to provide that ingredient into our product at a low cost.
Impossible is sold as meatless alternatives in restaurants and supermarkets in the US, Hong Kong, and Singapore. In the US, the plant-based meat market, including Impossible and others, is worth $1.4 billion US, making up 2.7% of all US retail packaged meat sales. Impossible says 9 out of 10 of its customers are traditional meat eaters.
Meat made from Impossible versus meat made from a cow uses 87% less water, 96% less land, 89% less carbon emissions, and contributes 92% less water pollution. If you were to purchase 1 pack of our retail product in store, that would be equivalent to saving 250 bottles of water. And those are the big bottles, the bottles that are 500 milliliters. Just with that 1 pack of Impossible Burger.
Other meats are heading in a similar direction. Like chicken, by far the most consumed meat worldwide. Tyndall is a plant-based chicken alternative with just as impressive carbon savings.
If you look at Tyndall and compare it to animal chicken, it's about 88% less greenhouse gas emissions, 82% less water consumption, and 74% less land.
Tyndall's plant-based chicken is made like this. There are 9 ingredients that go into it: water, soy, wheat gluten, wheat starch, sunflower oil, natural flavoring, coconut oil, methyl cellulose, and oat fiber. The sunflower oil and natural flavoring are what makes Lippy, a proprietary emulsion. Lippy gives Tyndall the aroma, taste, and cookability of chicken.
Put in a simple way, it's chicken fat made entirely out of plants. It's an emulsion made with natural ingredients, entirely from plants, that recreates all the experience you would expect from chicken fat. When you're cooking, you will see it manifesting itself through the browning, the smell, the taste, and when you eat it, you can definitely resemble that delicious chicken taste that we all love.
Tyndall, which is based in Singapore, was developed in collaboration with local chefs. Singapore was where Tyndall launched its global debut, and now has over 100 restaurant partners across the world.
When Singapore did set itself to become let's call it a Silicon Valley of food tech, the amount of transformation that has been happening has been quite substantial. If you compare back to 2018-17 to today, it's a completely different environment in terms of venture capital, in terms of startups, in terms of multinational companies with their R&D centers here, and universities developing as well their programs around sustainable food.
Among more recent entrants joining the fold is one startup that's making meat from microalgae.
Where there's water, there is microalgae. You can find it anywhere on this planet, in the ocean, in the freshwater. Sometimes you can even find it in the fossil records.
The microalgae is placed in a fermentation tank and fed food waste like spent grain, okara, and molasses. The microalgae grows, and it's harvested within 3 days and turned into a flour that's rich in proteins. Different strains of microalgae, also the way it's grown or fed, could determine different food flavors resembling different foods. The company plans to work with plant-based protein producers to replace soy and other flours. Flour from microalgae grows faster and uses fewer resources.
It will also be a lot more sustainable when you trying to produce it. And not only that, don't forget, microalgae has all the essential amino acids needed by the human being. It even has all the vitamin B group. So nutrition-wise, it will possibly be even better than all the protein flour that we're using so widely today.
Plant-based meat alternatives are one thing, but how about making meat without animals? Upside Foods, based in California, grows real meat from stem cells in a process that is similar to fermentation. In 2017, Upside Foods demonstrated the world's first cultivated chicken.
We take high-quality animal cells from cows and pigs and chickens, and we find the cells that can continue to grow and double and double and double just as they would inside an animal. At the end of it, when they touch each other, they start forming tissues just like they would in an animal. And then once they start forming tissues, they start developing thicker and thicker layers of muscle and fat and connective tissues. And when we start to cook our favorite foods, you start experiencing food as it should be, with the deliciousness and the desirability of meat, but not the enormous downsides that come with raising billions of animals to feed humans who love eating meat.
Traditional meat and dairy industries using livestock farming account for 14.5% of total man-made emissions. That's 7.1 gigatons of greenhouse gases annually. At scale, Upside expects its cultivated meat production to emit significantly fewer greenhouse gases. Independent researchers project cuts in emissions by as much as 90%.
When we talk about first principles, cultivated meat takes animal cells and grows them directly into meat, whereas an animal has to do a lot more. In addition to growing meat on it, it has to run around, heal broken bones, have babies. So it uses a lot of calories for things that are not going into making meat. So at a very simple level, with cultivated meat, all the calories we feed our animal cells are being used to make meat. So therefore, by a very vast margin, cultivated meat is going to be much more efficient in the world to produce meat with less resources.
Another Singaporean startup disrupts livestock agriculture in a different way. Turtle Tree makes milk in a lab. The process also involves stem cells, in this case from freshly expressed milk. Stem cells are grown in a bioreactor. Then, lactation is induced in turtle trees' patented lactation media, a liquid that contains various components naturally present in mammals. The process yields milk components, and these could be used to produce various dairy products.
It reduces greenhouse emission gas by as much as 78 to 96%, reduces water usage from 82 to 96%, and reduces land usage by 99%. So it's a far more efficient way and humane way to produce milk.
Turtle Tree says all milk from mammals could be produced using their process. Even infant milk powder, currently made with cow's milk. Another new development is the epitome of future food. Imagine if food could be made from just air.
Food out of thin air sounds like science fiction, but actually at Solar Foods we've been producing food out of thin air for more than 2 years. What we are going to do next is build our first commercial facility that we call the demo. It's supposed to be operating in the beginning of 2023, and after that we scale it to an industrial scale.
The company makes what they call soline, a protein that's produced with materials that are abundant in nature and a process that could even be carbon negative. That's because land now used for agriculture could be returned, so performing their original role as carbon sinks. It starts with a microorganism cultivated in a fermenter. No sugars or other agricultural agents are used to aid fermentation. Water from air is split by renewable electricity into hydrogen and oxygen. The cells are fed CO2, hydrogen, and mineral nutrients. Enough CO2 for the process could be captured from the air in an occupied room. The fermentation process results in a protein powder, which could replace agricultural products like soy and peas used in making plant-based proteins.
We can go literally to produce this food in the middle of desert, and it doesn't end there. We can go in urban settings because every one of us breathes about 1 kilogram of carbon dioxide out every day. We can capture, even from the ventilation of buildings, carbon dioxide that we breathe out, capture that and put it back into food in urban settings. Therefore, we can bring food production very close to very urban settings and within megacities of future.
An agricultural revolution is underway, turning what was once science fiction into reality. Bold new technologies are reducing the environmental impact of food production. It's now up to consumers everywhere to make the switch to more sustainably grown foods, an opportunity for everyone to be a climate trailblazer.